Maupay nga adlaw sa iyong tanan. Welcome to my channel. Our topic for today under subject Simplified Analytic Geometry as follow: angle of inclination, slope of a line, slope of parallel lines, slope of perpendicular lines, slope in terms of coordinates, angle formed by two lines, and area of triangle by coordinates. Let's start with angle of inclination. Let's consider a Cartesian plane with a line. For example, this is our Cartesian plane, and we have a certain line, line 1. So this is our x-axis, and this is our y-axis. The angle of inclination of a line, this is the angle of inclination by a line, noted by a symbol alpha, small letter alpha. Okay, so angle of inclination of a line, it is the angle between the reference point, so this is our reference line, x-axis, with respect to the line. Okay, so from, if this is our reference point 0, for example, we have a, in trigonometry, we have 0, 90, 180. As you can see, if we move our line clockwise, counterclockwise, this is your angle of inclination, or we called it the slope of a line. Okay, so again, angle of inclination is the angle with respect to its reference line, the x-axis, to your line, moving counterclockwise. So moving counterclockwise. So since the angle of our reference point is from 0, so it's clear that this angle is less than 90. Okay, let's draw another line. So this is our line 2. Again, the angle between the reference point and line 2 is our angle of inclination. Let's denote this as alpha 2. Okay, I hope it's clear the definition of our angle of inclination. It's only the angle with respect to the reference line x-axis to your line 1 or 2. Okay, let's move to slope of a line. The slope of a line depends on the degree of its steepness. Okay, let's draw another Cartesian plane. For example, this is our Cartesian plane, and we have a certain line. This is our y-axis, and this is your x-axis, your reference 0, and this is your line 1. Okay, so slope of a line, again, it is the angle, is the angle between your x-axis as your reference line. Called it theta 1. If it is short for theta, if it is short for line 1. The slope of a line may be also defined as the tangent of the angle of inclination. Here, our angle of inclination is this one. That is your angle of inclination. And the slope of a line is only your tangent of the angle. So, slope of a line or tangent of the angle. So, what is your angle here? Your alpha 1. So, your angle is your alpha 1. And the symbol for your slope, symbol for slope, or denoted as letter M. If M is your slope, therefore your M is equal to the tangent of your inclination, alpha. So that is your slope. Okay. It is obvious in angle inclination and in slope of a line that the angle your alpha is between 0 to 180 degrees, starting from 1 to 179 degrees. So that is the supposed angle of your inclination. Beyond that, it's become meaningless. Okay, so let's rephrase the slope of a line. So it is also defined as it's the rise over the run. Rise over the run. So rise for your y axis and run for your x. So for example, this is still your angle of inclination. So this is your rise and this is your run. So tangent. So we have our first formula. So moving to our slope of parallel line. Okay. Slope of parallel line. It is a line on the same plane but do not intersect. Far they may be extended are known as parallel of the line. Okay. So let's simplify muna. Parallel of a line. Usually the symbol for your parallel line is 2 bar. For your perpendicular line naman, it is like an inverted T. But of course, it is a 90 degrees. It's a right angle. So slope of a line, this symbol, and per perpendicular line, this symbol. Okay, going back to slope of a line. It is the same but do not intersect each other. For example, if this is our Cartesian plane, and we have two lines, this is your y-axis, this is your x-axis. So we have two lines. So symbol, look at the symbol. So if this is our line 1 and this is our line 2, it is obvious that whatever your angle for your line 1 is also the same in your angle in your line 2. Okay, it's a reference 0. So it's safe to say that your angle at line 1 is equal to your angle at line 2. Therefore, the tangent of your line 1 or angle of inclination of your line 1 and the tangent of your angle of inclination of your line 2 is equal. We can say that the slope of your line 1 is equal to slope of your line 2. This is true only for your slope of parallel line if two lines are parallel. So they are equal with their slope. Okay, let's evaluate with this slope of perpendicular line. So let's consider again a perpendicular line in our Cartesian plane. For example, this is your Cartesian plane. This is your y-axis, x-axis. So we have a perpendicular line. Again, look at the symbol. For example, this is our line 1. Line 1, line 2 is perpendicular to line 1. So if this is our line 2, so it's perpendicular. I hope it's clear to everyone what is a perpendicular line and a parallel line. Okay, going back to our discussion. The angle between the reference x-axis, you can say denote this as alpha 1 and the angle between the reference line 2 can denote this as alpha 2. Okay. If we evaluate the angle between the alpha 1 and alpha 2, it is obvious since perpendicular line they have a difference of between these two lines 90 degrees, we can say that our alpha 2 is only equal to your alpha 1 plus 90 degrees. Okay, so taking the tangent of both sides, so tangent of both sides, alpha 2 is equal to alpha 1 plus 90 degrees, and tangent of both sides, we can say that tangent of alpha 2 is equal to tangent alpha 1 plus tangent of 90, or and say tangent of alpha 1 plus 90. If we recall the property of our trigonometric, tangent alpha x is also equal to your negative cotangent. And your cotangent is equal to the reciprocal of your tangent. So therefore, your tangent alpha 2 is equal to the reciprocal negative of your tangent. Okay, So finally, therefore, the two lines perpendicular to each other if and only their slope are negative reciprocal. So therefore, replacing our tangent with the symbol of the slope, m is equal to your reciprocal of your slope of your line 1. So for a perpendicular line, line 1 and line 2, the slope of your line 2 is equal to the reciprocal of the slope of your line 1. That is what this formula say. Okay, let's move to slope in terms of coordinates. Slope in terms of coordinates, let's consider again a Cartesian plane with point 1 and point 2. For example, we have a certain line. So this is your y-axis and this is your x-axis. Okay. In terms of coordinates, let's consider 2 points. This is your point 1 and this is your point 2. So point 1 we have x sub 1 and y sub 1. Point 2 x sub 2 and y sub 2. Okay, so this is our run and this is our rise. Again, the slope is our alpha. As we recall, our slope is equal to your tangent of your alpha or equal to your m, the symbol denoted by your slope, m. So this is equal to your, with respect to the angle alpha, this is equal to your rise n over run, or also equal to the delta of y and delta of x. So delta is denoted as your increment, or simply the change in y and x. So if we're going to determine the value of our run is equal to your x sub 2 minus x sub 1. And for your rise, that is your y sub 2 minus y sub 1. So therefore, your slope m is equal to the change of y and change of x, which is the increment between x sub 2 and x sub 1 and y sub 2 minus y sub 1. So rise your y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So that is your slope in terms of coordinate. Okay, moving to our next definition of concept, angle formed by two lines. So angle formed between two lines. Two intersecting lines form four angles. Two pairs actually. So again, let's illustrate these two lines, intersecting lines. We have a Cartesian plane and we have two lined out intersecting each other. So this is our line. Okay, since still our x axis is still our reference line. These are y-axis. This is our line 1 and line 2. Properties of angle. Therefore, this angle between the upper and the lower side of the line is equal. Okay, so let's determine our angle. Oh, so that is your alpha 1 for your line 1, and this is your alpha 2 for your line 2. Okay. Again, by evaluation, it is obvious that your angle between two lines theta is equal to only the difference of your angle to alpha 1 and alpha 2. Or we can say our alpha is equal minus alpha 1 equal to or alpha 2. Okay, so taking the tangent of both sides again, so tangent theta tangent alpha 2 minus alpha 1. So again, trigonometric identities. Finally, tangent alpha 2 minus tangent of alpha 1, 1 plus tangent alpha 2 tangent alpha 1. Okay. Recalling our tangent is equal to m later. So finally, our tangent is equal to tangent of alpha 1 minus tangent alpha 1, 1 plus tangent alpha 2 tangent alpha 1. Okay, let's consider another setup of two intersecting line. For example, we have our Cartesian plane and we have this line. Okay, so considering this is our still our alpha or theta, this is our beta, and this is our line 2, line 1. In our figure A, if this is our figure A and this is our figure B, the first line to hit is our line 1, then line 2. Compared to our figure B, the first to hit is your alpha 2, seconded by your alpha 1 with respect to your x-axis as your reference line. Okay, so still by evaluating the angle of each line with respect to the reference x-axis, our alpha 2 plus our beta is equal to your alpha 1. Therefore, our beta is equal to alpha 1 minus alpha 2. And by inspection, here, our theta is equal to 180 minus this beta. Substitute the value of your beta, which is your alpha 1 minus alpha 2. Taking the tangent of both, taking the tangent of both, okay, you have tangent theta, tangent of 180 alpha 1 alpha 2. Okay, again by trigonometric identities na naman, finally we can say that this is your tangent alpha 2 minus alpha 1. Correction, this is supposed to be our alpha 1. Correction, this is your alpha 1 and this is your alpha 2. So transpose alpha 2 minus alpha 1. This is your alpha 2 minus alpha 1. Alpha 2, alpha 1. Okay, this is correct. So finally, by trigonometric identities again, your tangent alpha is equal only to the same as this one. So tangent alpha 2, tangent alpha 1 all over 1 plus tangent alpha 2, tangent alpha 1. Considering our definition for our slope, which is denoted by symbol m, your tangent alpha or theta is equal to your slope of your line 1, slope of your line 2 over 1 plus slope of your line 2, slope of your line 1. So this is your sixth formula. This is your fifth formula. Okay, I think we're ready for your sample problem. Okay, if we have a problem, example number 1, show that point A, B, and C and D are the vertices of a rectangle. Okay, our first step in solving this kind, it requires only to show to us that the vertices or the point A, B, C, and D are the vertices of a rectangle. So our solution is only to plot the given points. If what shape is the outcome. So point A, that is your 4, 1. So this is your point A. Your B, 2 and 4. 2, 3, 4. So this is your B. C, negative 4, and 0. And for your D, negative 2 and negative 3. So this is your D. Connecting these points from A to B, B to C, and C to D. Connecting these points. So it's obvious that the shape is rectangle with the vertices of these following points. To prove, you can use the slope to determine. For our next example, problem number 2, show that the points A, B, C are vertices of a right triangle and find the angle of triangle ABC. Okay. Still, our first step is to plot the given points always. We have a Cartesian plane. A 1, 2, 0. This is your point A. For your point B, negative 1 and 4. 4. This is your Y and this is your X. Okay. This is your B. For your C, negative 2 and negative 3. 1, 2, 3. So this is your letter C. So let's give them the coordinates. Negative 1 and 4. And for your C, negative 2 and negative 3. So let's connect the following points. Okay, so it's obvious based on visual evaluation alone, it's a right triangle. But we still have a second question. Find the angle of triangle ABC. Okay, so start with our slope at A. So slope at BC. So recall RM or slope by evaluation, slope of your angle BC, and for your slope 3, slope of CA. Maybe we should determine first our M1 or slope 1. Slope 1 using the coordinates of the given points. So going there, this is your YB minus YA over XB minus XA. Therefore, we have 4, 0, and negative 1 and 2. Therefore, our slope 1 is negative 4/3. Same with our slope 2. So slope 2 is our y, our c, and b. So this is yc minus yb over xc minus xb. For this negative 3 and 4, negative 2 and 1. Therefore this is negative 7 over negative 1. This is 7. For your M3, YA, YC, XA minus XC given 0 and negative 3 over 2 is negative 2. So this is 3/4. Okay, notice it's only a reciprocal. So finally, we can determine our M2. Our M2 slope is 7 and our M3 is 3/4. Now let's find the tangent of your angle C. Slope of your M2 minus M3 over 1 plus M2 M3. 7 3/4 over 1 plus 7 3/4. Finally, our tangent C is equal to 1. So C tangent 1 C is equal to 45 degrees. Okay, so therefore if RC is 45, so since it's a right triangle, so this is 90, therefore this is also 45. So summation of your angle, it should be 180. So it's clear that this is a right triangle. So 45 plus 45 plus 90, that's 180. So it's check. Okay, let's move to our next discussion. Area of triangle by coordinates. So this is a formula-based formula. So let's consider vertices in a certain coordinate plane. For example, if we have a Cartesian plane and we have vertices of our triangle. For example, this is our point 1, point 2, and point 3. So of course, this is your x sub 1, y sub 1, x sub 2, y sub 2, x sub 3, y sub 3. Just using our formula. Formula for this is area with respect to your point 1 and 2 and 3 is equal to 1/2 matrix form of your x sub 1, y sub 1, x sub 2, y sub 2, x sub 3, and y sub 3. So this is your formula for your area of triangle by coordinates. So for example, if we have example for this problem, find the area of a triangle whose vertices are A, B, and C. So let's plot, or we can directly substitute the given coordinates to our formula. If we have a formula, if these are x sub 1, y sub 1, x sub 2, y sub 2, x sub 3, y sub 3. So let's directly substitute to the formula. Our area for ABC is equal to 1 half the matrix form of your x sub 1, y sub 1, 1, x sub 2, y sub 2, 1, x sub 3, y sub 3, 1. Okay, just follow the formula. 1 half. So first, x sub 1 times y sub 2 minus y sub 3 plus x sub 2 y sub 2 minus y sub 1 plus x sub 3 y sub 1 minus y sub 2. Substitute the given formula. So x sub 1 substitute the given vertices. Four, 1, 1, 1, 2, 1, negative 5, negative 1, 1. Properties of your vertex to complete the basket method. So 4, 1, 1, 2, and negative 5 and negative 1. So let's follow. So 1, 2, 3. So follow with your 1, 2, 3. Finally, your area is 1 half a 5, 1 minus 10, 4 plus 1 is equal to 1 half 2 plus 13 equal to 15 over 2. So your A is equal to 7.5. So the area of your triangle whose vertices with the following is A is equal to 7.5. So there is no unit. You can use units. Square units. Okay, for your exercise number 4, you can submit your answer and solution to your Moodle account. So that's all for today, and have a nice day everyone.